Right, this is the 2014 updated CAT question 1. So lots of ways to do this. You could cross multiply. We're multiplying by 2 actually. So we get 16 equals 5x minus 4. Adding 4 to both sides will give 20 equals 5x. It's adding 4 to both sides. And then dividing by 5 both sides gives x equals 4. Okay, 2, it says to factorise. So CFF, common factor first. Have a look through, see if you can find something that's common. All the 3 terms have an a. In fact, they all have an a squared in them. There's an a times a in that term, a times a times a, and a times a. So they all have an a squared, and they all have one b. There's no numbers in common at this stage. Right, a squared b, we're going to need to times that by 3 to get 3a squared b plus. Now to get that middle term there, I need another a. I need to multiply by another a and another b to get the b squared. Minus, we need a 5, and I've got the a squared b. Now just before we rush on, you should look inside the bracket. Make sure there's nothing else common or anything else you could simplify. And I can see that if I do the 3 take away 5 is minus 2 plus ab. And now I'm confident we might like to rewrite that with the ab in the front and minus 2. Alright, part C. Mark had worked twice as many hours as James. So we've got Mark and we've got James. If James works x, then Mark is going to be 2x because he's worked twice as long. If James had worked another 48 hours, he would have worked twice as long as Mark. Twice as long. So it would be double what Mark did. So 2 times what Mark did would be the same as James if James had done an extra 48 hours. So that's quite complicated, but what we're saying is if we double the number of hours Mark worked, it would be the same as James if he'd worked another 48 hours. 2 times 2x is 4x. We're going to minus x from both sides. Divide both sides by 3. Depends how well you can divide 48 by 3. A little bit of long division. 3's into 4 go once, remainder 1. 3's into 18 goes 6. Or you might know it's 16. We need to go back and check. The question says how many more hours had Mark worked than James. So I think that James worked 16. Mark worked twice as many. We might just check if we'd added another 48 hours onto that. We would have got 64. And in fact that would then be twice as long as what Mark did, because 2 times 32 is 64. So I'm confident in my answer. The question does say how many more hours had Mark worked than James, and I can see that Mark worked 16 hours more than what James did. So you need to be writing Mark worked 16 hours more than James to fully answer the question. Right, part D. I'm going to write that over 1, and I'm going to do some cross multiplying. So 4x minus 6, or simply multiplying by 3 both sides is actually what I'm doing. (6x plus 3), expanding carefully. I'm going to subtract 4x from both sides to keep the x's positive. Then I'm going to minus 3 from both sides. Minus 3 minus 6 is minus 9. Careful with the integers. And then we'll divide both sides by 2. So I get x is less than or equal to minus 9 over 2. Alright, and on to the next page for the last question. Just make it a bit bigger. We're asked to simplify. You can't simplify top and bottom, numerator and denominator, unless there are factors present. So we're going to need to factorise and get ourselves some factors. The bottom line looks easiest because I can see there's a common factor of r. If we common factor first and pull out the r, leaving me with r plus 1, just check that that would give you r squared plus r. Now looking at the top line, it's not clear that there's a common factor first, and there isn't. But what you might notice, hopefully, is that 1 is a square number, and r squared are obviously r times r, and this is 1 times 1, and I want the difference between them. So we're asked to factorise a difference of two squares, which we can do by writing r minus 1, r plus 1. And so now I have factors on the top line, factors in the denominator as well, and I can see the same factor occurring numerator and denominator. So we can cancel those out, and I'm left with r minus 1 over r. Now it would be tempting to cancel out the r's at this stage, except that we have the subtraction on the top line, so rather than having factors. And if you're ever wondering about that, you could try with an example and ask yourself what that might equal. 3 minus 1 is 2. It should equal 2/3. But if you come along and see the same numbers and just cancel, you wouldn't get 2/3. So that's why it's really important that you can't cancel anymore at that stage.